This video is about steel, everything steel. Steel hardware, steel tools, steel building materials, even your steel cutlery. I made this video to help you choose suitable materials for your project. You ever found yourself not understanding store terminology? You ever wondered why prices of identical looking steel items differ so much? You ever wondered if maybe you are led by marketing claims? Well, to take the mystery out of all this, we have to start at steel classification. This steel classification is quite universal, but on the top right hand corner you can see some organizations that develop standards that relate to steel production. Manufacturers are not at all at liberty to make any kind of steel they feel like. The steels they make have to correspond to standards. These standards, again, some of the organizations are Society of Automotive Engineers, American Iron and Steel Institute, UNS is an international steel classification system, and EN is European norms or nomenclature. Now, the steel classification and these types of steels have a very important reason why manufacturers can't just make any kind of steels, because these standards regulate the chemical composition of steels. I'm going to explain this because the chemical composition of the steels dictate its mechanical properties such as strength, and engineers can't design and specify steels that are strong enough for or suitable for a particular purpose without consistent, reliable grades of steel or types of steel. So that's why steels are classified and classified according to standards, so that they have a uniform composition and they perform reliably, uniformly. Okay, let me fill you in on some of the details. First off, the steel composition. All of these steels must have iron in them. Okay, if it's naval brass, it's not a steel. All steels have iron, and I wrote iron here, abbreviated by Fe, and all steels again contain carbon. Okay, not only the carbon steels contain carbon, but all of them contain carbon. They must, otherwise it's not steel. Now come on over to the periodic table of elements, because steels contain other elements as well, and I circled some of them. I don't know how well you can see this, but I'll point them out one by one. Here is carbon and here is iron. These are the two main characters that can be found in every steel. Other elements that are also added to steel are vanadium, chromium, manganese, cobalt, nickel, molybdenum, tungsten, and to a lesser degree silicon. Two of the bad guys that steel manufacturers should get rid of are phosphorus and sulfur. These two elements make the steels weaker, and the industry standards specify how much effort should be going into purifying the steel to get rid of these two elements. Now, come on back over here. Let me just explain one more thing about these groups. So, the carbon steels here, and again, this designation might be a little bit misleading, but don't worry about it, just work with the system. Carbon steels have low carbon, medium carbon, and high carbon subdivisions, and they are just called carbon steels, but again, all other steels have carbon in them. Alloy steels is the next group. Alloy steels have, other than iron and carbon, more or other elements that are added to it in precise amount as per designated by the standards. Some of those elements are chromium, vanadium, molybdenum, nickel. And there are other alloy steels as well. This is not a comprehensive metallurgical course. This is just to help you as a consumer choose more suitable materials for your projects and have a little more consumer savvy when it comes to buying items and have a better grip on value behind the items. HSLA stands for high strength low alloy steel, and high strength low alloy steels have also low carbon but also low alloy, and so they are in the alloy steel group. The next one is tool steels, and again this designation is somewhat misleading because some tools are made out of medium carbon steel or high carbon steel. Some tools are made of alloy steels and some others are made out of stainless steel. However, just one group is called tool steels, and very specific tools only are made out of these tool steels. These W and these letters stand for water quenched, oil quenched, air quenched, and this one stands for high speed steel. So those are tool steels. The next last group is stainless steels, and austenite and martensite are words that refer to the crystal lattice structure of iron. And usually I make an analogy with snowflakes. All snowflakes are made of water, okay? But there are hexagonal snowflakes and snowflakes that look like spikes, snowflakes that look like a rectangular solid, snowflakes that have different more branches or fewer branches or more branchlets, and all of the snowflake shapes have different crystal structure, but they are all made of water. Likewise, these are two crystal structures that iron can take up, and duplex just means that that particular group of stainless steels have characteristics of both crystalline structures. Now, where the classification and standards are really important, like I said, is when it comes to mechanical properties. And maybe just come down a little bit and a little closer. Here on this sheet of paper I have, how do I do this? On that sheet of paper I have, yes, okay, that's good. I have Society of Automotive Engineers designation of carbon steels, and you can see that carbon steels have a numbering systems, and from here down everything is alloy steels. And you can see manganese steels, nickel steels, and the rest. Okay, so there's all kinds of alloys. Now, again, why steels are classified is that they have calculable, reliable, consistent mechanical properties. Look at the bottom here on this sheet here. You can see the component elements that make up this 1080 high carbon steel. Now, you can see the amount of carbon that it has to contain, the amount of iron that it has to contain. Manganese, oh, I forgot, manganese is added to all steels. I'm not, maybe not recently, but kind of fairly recently. Okay, say 50 years back or so, because it makes iron rust less. And here are the two bad guys, sulfur and phosphorus. Their maximum amount is specified, and these numbers tell the manufacturer how much effort they have to put into purifying the steel before it can be called a 1080 steel. And here you can see mechanical properties of the steel. Its hardness, its strength is listed there. Its modulus of elasticity, so how flexible it is, how much impact it can take before it breaks. You can see electrical properties listed, thermal properties listed, and again, steels are classified and manufactured in a way that is governed by industry standards, so their mechanical properties are consistent. All right, now I have samples of steels around here. We just have to turn around and take a look at some of these, and I will tell you more about characteristics of steels. Let me just lower this camera here. That's about a good spot. Okay, low carbon steels. Low carbon steels are cheap because they are made in huge amounts. Probably the low carbon steel is the steel that's made the most of. Low carbon steel therefore is cheap because it's widely available, but it's also weak or bendable, and if the teeth weren't hardened on this one, it wouldn't be able to, this is a saw blade for a hacksaw, this hacksaw blade wouldn't be able to cut through anything. You know how easy it is to bend a nail and straighten it, so that's low carbon steel. Low carbon steel also rusts. As soon as the protective paint is worn off, it rusts in no time. If you leave out a box of nails in a rain, they are all rusty in an hour and a half. This one here is an electrical junction box. It's also galvanized, but it's still low carbon steel, and it's made and press folded in a fashion that is similar to making cookies out of dough. So they are very highly formable, and you can cut it with a tin snips, and they also rust, like I said, heavily. And a special group of low carbon steels is called mild steel or structural steel, and structural shapes are manufactured like tube and piping, hollow structural steels, I-beams and everything, and reinforcing bars or rebar for concrete. So this is inside the concrete, and this rebar has to be somewhat flexible, and it's got to have a certain amount of give to make sure that the building doesn't collapse, because if this one failed in a snap, it wouldn't be any good. It has to have a certain amount of give. Now, next group over is medium carbon steels. Medium carbon steels are also cheap because there's lots of them. Shafts and axles are made out of medium carbon steels, as well as tools like screwdriver bits, fasteners like nuts and bolts, and some cheap chains. Not all chains are equal, actually, and I'll tell you more about chains when we move higher up the food chain. Drill bits that are designed to be resharpenable, typically auger bits, spade bits, and are designed to be resharpened many times. They're like these big bore bits, and because they are meant for rough use and therefore resharpened. Now, what happens when these fasteners, for example, don't comply with the precise chemical composition that's specified in those industry standards, is that you have substandard materials. And this one failed, and upon a metallurgical examination, it was determined that its chemical composition doesn't conform to any known standards. So this is what happens when stuff gets made in countries with no quality control. Lives could be at risk if some of the fasteners fail, and this bolt particularly had so much slag, included slag and impurities like phosphorus and sulfur, it was off the chart. Okay, moving over to high carbon steels. High carbon steels, and I have some tools here. A hammer is high carbon steel, and so is this sprocket here. High carbon steels also rust, just like pretty much every steel rust. More about it when we get to the stainless. You can see on the label here that indeed this is high carbon steel, conforming to the 1045 on the numbering system type steel. And high carbon steels are strong, a lot stronger than medium or low carbon steels, and they extremely wear resistant. But you can't, it also means that you can't really drill them, you can't cut them with a hacksaw, you cannot file the claws on a hammer really successfully. They do wear, and it is possible to machine them or drill a hole in them, but it's not going to be easy. High carbon steels are also not weldable, and that's why you can't really weld on claws on a hammer when they break off. Here is some rigging hardware, like wire cables. These are also made of high carbon steels. Moving over to the next group, alloy steels. In the group of alloy steels, if you remember, we had chrome vanadium steels, chrome molybdenum, chrome nickel, and such. So here is a socket. This is a 6-point socket, and this is an impact socket, and it's chrome molybdenum steel. There, I have here a label from another tool that is also a chrome molybdenum tool, and this wrench here is, sorry, other side. There we go, chrome vanadium steel. And drop forge means something else. It doesn't refer to its chemical composition. Some high-grade chains, like chain grade 80 and grade 100 chains, are alloy chains, and the only chains approved for overhead lifting. So all the other rigging hardware, they are good for tying down load on a truck, or tying your doggy to a tree, but not for overhead lifting, because alloy steels are even stronger than high carbon steels because of the alloying expensive elements. Vanadium and tungsten and nickel are expensive. Alloy steels are expensive and extremely wear resistant. So these sockets should last me a lifetime easily. Next group over is a group of stainless steels. Now, stainless steels are have 2 or 3 different crystalline structure. Again, could contain austenite or martensite, or a mix of both. Some stainless steels are soft and flexible, but are a lot stay a lot sharper and harder than just the low carbon hacksaw blades that we looked at. Also equally soft, but stainless steels stand up to use a lot more or a lot better. Dentistry items and surgical items, yeah, there's no such thing as surgical steel, okay? It's either martensite or austenite. There is no or duplex stainless steels. There really is no surgical steel in any nation's designation. Some stainless steels are harder and stiffer, and some stainless steels, like this bracket, are not magnetic, but some others are. typically the stainless steels that have austenite in them, they are not magnetic. They are also extremely corrosion resistant. This is not corrosion, this is a little bit of residue. This bracket has been in a wet place in a kitchen for 17 years, and that's really not corrosion, that's just some deposit on it. It stood up to use without failing. 17 years. Now, this is where the tricky part comes in. Look at this one. This one says on it, stainless steel China. What do you see on it everywhere? Rust. Yeah. So anybody can print stainless steel on their product, but by claiming so doesn't make it so. And this knife came out of this kit here. You can see the price matches my expectations and the product's performance. So if you see stainless steel items that catch a pretty dollar, don't be afraid to fork it out, because if you pay that much, that's what you get. Moving over to tool steels, and I just picked two subcategories out of it. This one is a water hardened plane blade from it's a woodworking plane, and this is a high-speed steel drill bit. There are drill bits made out of high carbon as well. The high-speed drill bits are a lot more expensive. They are also a lot stronger and a lot more resistant to wear. So high carbon drill bits will go dull. High speed drill bits will not go dull so easily, because these blades are extremely wear resistant. That also means that rehoning and resharpening these is gonna be an effort. Lastly, I've got here a set of 4 labels, and on it, let's see if we can spot some abnormalities, I say. This one reads 10-inch pipe wrench, quality steel construction. Yeah, quality steel is not a term that's used in industrial standards. The term quality steel does not refer to any classes of steels and doesn't guarantee any set of mechanical properties. Okay, so quality steel as such, yep, it's not happening. Next one, just as cute. Here is this Husky label, high strength steel. The same story. There is no such thing as high strength steel. There is high carbon steel, there is high speed steel, there is no high strength steel, and there's a label on it from the American National Standards Institution or Institute. That's what ANSI stands for. ANSI doesn't regulate or specify steel grades and steel performance and their mechanical properties. So I don't know what to make out of this high strength steel. High strength steel can be abbreviated as HSS, just like high speed steel, which is legitimate steel type, but high strength steel, I don't think so. Next one, 2 packages of drill bits by Bosch. One is high carbon steel, one is high speed steel. The high carbon steel, 5 pieces cost $3. High speed steel, 2 pieces cost $5 or something like that. So these are good examples. And another good example as well is on this planer, thickness planer knives by Delta. It says double-edged high speed steel. So there you have it. These are some labels that are justified and legitimate, and some others that are more on the creative side. So that's all I have to say about steel classification, and I hope these ideas help you demystify the subject of types of steel.